Chapter 4.6, we're looking at graphs of other trigonometric functions. We're going to sketch the graphs of tangent, cotangent, secant, and cosecant functions. So let's take a look at tangent. Recall that the tangent function is odd. That means that if you plug in negative for x, it's negative tan of x, and it's symmetric with respect to the origin. So just to fill out the table, we want to sketch the graph so we can see what's happening here. Remember that these values correspond to the unit circle. So just looking at 0, tangent of 0, that is 1, 0. Tangent is y over x, so therefore at 0, we're at 0. Then at pi over 4, that's root 2 over root 2, which is a positive 1, pi over 4 here. At negative pi over 4, we're at negative 1. Now just to plug in some more numbers to see what's happening with our graph, if we plugged in 1.5 in the calculator, you would get 14.10. If I plug in 1.57, so just a little bit more than 1.5, you would get 1,256. Then now let's get pi over 2. Pi over 2 is here, and that is x is 0, y is 1. So that is 1 over 0, and it is undefined. Okay. Then at negative pi over 2 down here, it is also undefined. So we notice that the period of tangent is only a pi. Okay, because it's undefined at those two spots. Then you'll notice if you plug in a negative 1.5, you will get a negative 14.10, and negative 1.57, you would get negative 1,256. So let's sketch our graph. We know that at 0, 0, that is our point there. Now, we know it's undefined at pi over 2 and negative pi over 2. So those are the asymptotes, pi over 2 and then at negative pi over 2. Then at pi over 4, so notice that's half of pi over 2, so it's pi over 4. And at negative pi over 4, we have some important points. At pi over 4, we're at 1. And at negative pi over 4, we're at negative 1. So this is the graph of tangent, and we could continue this graph. So this is 3 pi over 4. This is pi. This is 5 pi over 4, and then it just goes backwards. Okay, then you just repeat it. So notice that the intercept is here at that pi again. So at 0 and then pi, and then it's at negative pi, and I'm sure you can guess where the next intercepts are. So the domain is all real x, all x, except x cannot equal pi over 2 plus n times pi. So all these pi over 2, you're going to add pi, and that's where all the asymptotes are going to be, or even subtracting it. The range is from negative infinity to infinity. The vertical asymptotes are at that x equals pi over 2 plus n times pi. Okay. Then the x-intercepts, we know that's n times pi, comma, 0. So it's at 0, it's at pi, it'll be at 2 pi, and so forth. Y-intercept, it's just at 0, 0. Now we're going to find, you can find the vertical asymptote. So one way to do it is using this. So find vertical asymptotes. Using bx minus c equals negative pi over 2, and bx minus c equals positive pi over 2. So I want you to notice on the parent function, the furthest left is negative pi over 2, and on the right, the furthest is pi, positive pi over 2. So that's how you find the vertical asymptotes, one way of doing that. So let's try sketching the graph of a tangent function. Sketch the graph of y equals tangent of x over 2. So we want to look at, let's see, the period. So remember that the period of tangent is a pi. So the period of pi, we can say is pi over b, and b in this case equals 1/2. So this is pi over 1/2, which is 2 pi. So to find the left side, the asymptote, so x over 2 equals, and we set it equal to the negative pi over 2. Then we find, when we multiply by 2, the x is negative pi, So that's our furthest left. And then on the right side, we're going to do the same thing. X over 2 equals positive pi over 2. Multiply by 2. So the furthest right will be pi. And so you go 2 out. This is pi, and this is negative pi. Then we know that tangent is at 0, 0. It's not shifted anymore other than that. There's no amplitude, but it's 1. So it's going to be right 1 or right pi over 2, and then it's 1. And then at negative pi over 2, we are at negative 1, and then it goes this way. Okay? And then you could fill in the rest as well. So you get a complete graph there. So this is pi, this is 3 pi over 2, this is 2 pi, and then 5 pi over 2. And then it goes to the left. Negative 3 pi over 2, negative 2 pi, and 5 pi over 2. Now it's up to you. You can always solve for the interval this way. Or another way to think about it is that you know that the period is pi, and in this case, this particular case, we know that it's 2 pi. Notice it's 2 pi, and we just take half of that, and that gets us our asymptotes. Then another half of that will get us those important points here. So it's another way to think about it, but it's something you have to memorize. So it's up to you, however you want to remember how to graph tangent. So try one example here. Sketch the graph of y equals tangent of x over 4. So we tried it out. The period was 4 pi. If you plugged it in to try to figure out the left and the right, then you plugged in x over 4 equals negative pi over 2. So this equals negative pi over 2. So x equals negative 2 pi. And then on the right side, x equals 2 pi. Let's do one more, sketching the graph of a tangent function. And so just a little more transformations on it. So this is reflected, it's vertically stretched by 3, and the period is also changed. So I could figure out the period, or I'm just going to do the 2x, so b, 2x equals negative pi over 2, and then divide by 2. And so I know that x equals negative pi over 4. Then I know on the right side, I don't have to do the math on that. I know it's going to be positive pi over 4. So let's sketch that. Negative pi over 4, half of negative pi over 4 is negative pi over 8. So pi over 8 and pi over 4. And then starts here. It's reflected, so I know on the right, it's going to go down 3. And then on the left, it's going to go up 3. And then so that is 1 period of tangent. And then I can repeat. Then labeling the x-axis, 3 pi over 8, 4 pi over 8 is pi over 2, and then 5 pi over 8, and then you continue to label the rest. Okay, if you need one more example, try this example, and then that will be it for this video. Okay, we tried this out. Sometimes labeling the x-axis is the hardest. So this is pi over 4, negative pi over 4, and positive pi over 4. Half of pi over 4 is pi over 8. Now remember to jump to the other values. So this is pi over 8. Add another pi over 8. That's 2 pi over 8, which is pi over 4. Then this is 3 pi over 8. When 3 pi over 8 plus another pi over 8 is 4 pi over 8, or that reduces to pi over 2. And then this last one is another pi over 8 is a 5 pi over 8.